Hello, this is Dr. Armand bringing you another exciting lecture in general chemistry. In this lecture, we'll be looking at covalent compounds, molecules, how to name covalent compounds, and also a specific class of covalent compounds called hydrocarbons. We'll look at naming those as well. So sit back, relax, and enjoy the show. So before we delve into the world of molecules and covalent compounds, we're going to take a look and just kind of review over naming polyatomic ions. And so we're going to go through a few examples and then kind of give you the tips on how to name these compounds. So the first one is, what is the formula of ferric hydroxide? So ferric, here we're using the common naming for this compound. Ferric indicates the ic, indicates the higher charge, and ferric comes from ferrum, or ferrum, excuse me, which is the Latin name for iron. So here we're looking at iron, Fe, and Fe can be one of two charges. It can be a +2 or a +3. And so if we're looking at ferric, we're looking at the higher charge, so we would use the +3 here. So we know that iron is a +3, so we have our cation. Now hydroxide is a polyatomic ion that contains hydrogen and oxygen. And so if you notice that oxide is a -2 charge. Now hydroxide means that we put a hydrogen onto the oxygen. So when we add a hydrogen, it becomes a -1 charge because hydrogen is +1. Now if we added another hydrogen, guess what we get? We get water. So hydroxide is just adding one hydrogen to oxide. And so now if we write our two ions, we have Fe3+ and OH-. So here we can do this crisscross and determine the number of each. And so we get here that the answer is FeOH3. So that's the formula of ferric hydroxide. Next, we want to give the name of SnCrO4 2. So Sn, the symbol for that is 10. And CrO4, well, we have 4 oxygen, but it's with chromium, so this is chromate. Now, since chromate has a -2 charge, we don't use the per in front of it. So it's not perchromate, it's just chromate. Because again, chromate has a -2 charge, so we do not use the prefix per. So far we have 10 chromate. But 10 is one of those elements where we have to include the Roman numeral. And here, if you were to do the reverse crisscross, you would get the incorrect charge of 10, because you have to remember that we have 1 10 whose charge is unknown plus 2 chromates with a -2. And this has to equal 0. So then we get x to equal +4. So there's two ways you could write this. You could say 10 for chromate, or you could say stannic chromate, because 10 has a high charge and a low charge. It's +2 and +4. So since this is the higher charge, you could write it in its common name as well, or the systematic name. So 10,4 chromate or stannic chromate. Next we have we want to write the formula of silver acetate. So silver, the symbol is Ag, and silver is one of those transition metals that only has one charge, and its charge is a +1. And we have acetate, which is can be written two different ways. I'm going to write it as CH3 COO minus. So when we do the crisscross, we get AgCH3 COO. Or sometimes you may see it written like this, AgC2H3. So either way is okay. Next, we want to write the name of NH4 HSO3. Now here you see we have no metal in the formula, but there's something unique about this right here. And this is one of the few polyatomic cations that we have, and its name is ammonium. Not to get confused with ammonia. Ammonia is NH3, ammonium is NH4 plus. Next we have HSO3. So HSO3, if you notice here, HSO3, we have the anion SO3, we have a hydrogen attached to it. So SO3 is sulfite. When you add a hydrogen to it, it becomes hydrogen sulfide. So you can name this compound ammonium hydrogen sulfide, but since SO3 is a -2 charge, we get HSO3 minus. So we can also write this as ammonium bisulfite. But you cannot do the bisulfite with, or you can't use the bi prefix for those anions that you have add a hydrogen to, that the non-hydrogen ion doesn't start with a -2 charge. So for example, if it was a phosphate, you can't say bisphosphate, it doesn't work. Bisulfate works because, or bisulfite works because sulfite has a -2 charge. You can only add one more hydrogen to it to still have an anion. Next, we want to know what's the name of Mn2O23. Now this is interesting here because this is not so common anion, but the cation is manganese. Now the anion is O2 2 minus. And this is one of the few cases where oxygen doesn't have a -2. But when you see the polyatomic ion O2 2 minus, this is peroxide. And peroxide is when oxygen has a -1 charge. So O2 2 minus means each oxygen has -1. So here you can do the reverse crisscross, and the way you know you can do the reverse crisscross is typically you have an even odd combination. That's a good indication that you can do the reverse crisscross and determine the charge of each. So here we get that manganese is a 3. So we should write it as manganese 3 peroxide. So you have to make sure you include the Roman numeral because manganese can have more than one ionic charge. Now you can't use the common naming for this because manganese has more than 2 charges. It has anywhere from +2 to +7 typically. And so you always have to include the Roman numeral. For our last example, we have Pb HCO3 4. So here we have the cation is lead. Now the anion is HCO3. So here you'll notice that CO3 is carbonate, and we've added a hydrogen to it. So our anion is hydrogen carbonate. But now we have to know, okay, what's the charge of lead? Because lead is one of those cations that has more than one ionic charge. And so bicarbonate, you know, if we have CO3, carbonate is 2 minus. When you add a hydrogen to it, HCO3 minus, it becomes. Because whenever you add a hydrogen, you have to add +1 to the charge. So this, since you have a bicarbonate that's a -1, and you have 4 of them, that tells you that lead has to be a +4. And so this can be lead 4 hydrogen carbonate, or you could write it as lead 4 bicarbonate, and you can also write it in its common name, because lead only has a +2 or a +4. So with that, we can also write plumbic bicarbonate or plumbic hydrogen carbonate. So either names are acceptable. So again, you have to know those polyatomic ions. The best way to do that is by making flashcards. One side have the formula, the other side have the name. So now switching gears to covalent compounds. Unlike ionic compounds, which are made up of ions, covalent compounds are made up of molecules, and molecules contain at least 2 atoms in a specific arrangement, and they only contain nonmetals. So molecules can only contain nonmetals, and these are held together by covalent bonds, which involve sharing of electrons, in contrast to ionic bonds, which involve the transfer of electrons. And there are many different types of molecules. The first ones are called homonuclear diatomic molecules. So diatomic means 2 atoms that make up the molecules. Homonuclear means they're the same type of atom. And so you need to know that these elements exist as diatomic molecules. So hydrogen, iodine, nitrogen, oxygen, chlorine, fluorine, and bromine all exist in nature as diatomics. Whenever you're reading a problem and it mentions hydrogen gas, it's referring to H2 gas. And a neat little acronym to remember this is BRING, COL, HUF. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Another type of molecules are heteronuclear diatomic molecules, and these are molecules made up of 2 atoms. Diatomic means 2 atoms, but there are different types of atoms like HCl, ICl, CO, etc. And then lastly, the third group of polyatomic molecules contain, more than 2 atoms that are different types of atoms. And so there's a whole slew of polyatomic molecules: CH4, NH3, H2O, SO2, CO2, what else? SF6, etc. So lots of polyatomic molecules. And we're going to learn how to name these polyatomic molecules, these molecules with 2 different types of nonmetals as covalent compounds. So first off, we need to look at these Brinkelhoff, or these molecular elements. So there are some elements that exist as molecules, and sometimes we have elements that occur in more than one type of form. And so these are referred to as allotropes. So allotropes are one of 2 or more distinct forms of an element. So it's the element, but it's different form of the element. So for example, oxygen has 2 allotropes: oxygen gas and ozone. Oxygen is what we breathe. Ozone is what protects us in the upper atmosphere from harmful ultraviolet rays. Carbon has a bunch of different types of allotropes. So carbon graphite and carbon diamond. You can see the different types of structures. Carbon graphite is planar, which has formed sheets. Diamond is an intricate three-dimensional network. There are also fullerenes, which is a big C60 ball, or carbon nanotubes. These are all different forms of carbon. And then one other one, we have phosphorus, P4 white and P4 red. So white is a molecule made up of 4 phosphorus atoms, whereas red, as you can see here, is this extended chain of phosphorus atoms. And so some elements, now these are not all the elements that have allotropes. There are different elements that have allotropes. These are just some examples. But again, we mentioned the diatomic molecules, elements, molecular elements. So that's the Brinkelhoff, the ones in pink. Tetraatomic is phosphorus. Phosphorus is the only nonmetal that's tetraatomic. And then octaatomic is sulfur and selenium. So sulfur and selenium exist as one big molecule of 8 sulfur or 8 selenium. So those are octaatomic. And so you should know the different elements in these 3 groups. Primary importance is to the first group, diatomics, because it's very important to know these for future chapters. But you should also know tetraatomic and octaatomic. So naming type 2 compounds that only contain nonmetals. So these are binary compounds that contain only, again, I have to stress, only nonmetals. That's when you use this naming scheme, only when you see nonmetals in the formula. And these are binary covalent compounds, so covalent compounds with 2 different types of atoms. The first name of the element in the formula is the name of the element. So whatever element is listed first, that's just the name of the element. The second element in the formula is named as if it is an anion. So you have 2 elements in a covalent compound, at least in the binary covalent compounds. The first element is just the name of the element. The second element is the name of the anion. And we use prefixes to denote the number of atoms of each element. And these are the Greek prefixes. And so it's very important that you remember these prefixes. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, dodeca for 12, etc. Now, for mono, we never use it in the first element. So for example, if we had the element CO2, which everyone knows about, we don't say mono dioxide, we say carbon dioxide. So again, since there's only one carbon in the first element, we just say carbon, we don't say monocarbon. Since there's 2 oxygen, it becomes dioxide. So this is a good way to remember that we never use mono in the first element. You think of carbon dioxide, we don't say mono carbon dioxide. So BF3, we have 1 boron and 3 fluorines. Since fluorine is listed second, it's going to get the name of its anion, and it's going to use the prefix tri. So this becomes boron trifluoride. Again, notice that there's only nonmetals in the formula. NO doesn't spell no, it spells, we have nitrogen and oxygen. Since oxygen is second, it's going to be the anion oxide in the name. So nitrogen monoxide. N2O5, we have 2 nitrogen and 5 oxygen. So 2 means di, 5 means penta. And we have dinitrogen. And you can either say pentaoxide or pentoxide is fine. You can drop the A since it starts with a vowel. So you can say dinitrogen pentaoxide or dinitrogen pentoxide. CF4, 1 carbon and 4 fluorines. This would be carbon tetrafluoride. Now, the ones that have hydrogen in them, they have special naming associated with it. So one exception to this systematic naming is NH3. Since you see a hydrogen there, this tells you it's going to use an alternate naming. It's not going to use its systematic naming. So NH3 is referred to as ammonia. CH4, which is a hydrocarbon, which we'll talk more about in just a moment. This is the hydrocarbon with one carbon and 4 single bonds. This is methane. So you notice that the binary covalent compounds with one of the elements is hydrogen, we have a different naming for them. There are exceptions to the normal systematic naming. pH3 is phosphine. Again, it's a different name than the systematic name. So make sure you remember that the exceptions of these. Now, one other exception that we all should know is H2O is water. So we're going to talk more about the hydrocarbons such as methane, but you should remember that ammonia, phosphine, and water are exceptions to the systematic naming. So they use their common names that are mentioned here. Now for hydrocarbons, which we'll talk about in a minute, they have their own naming scheme. And hydrocarbons only contain hydrogen and carbon in the formula. So here we have some examples. We have ClO6, Cl3O6. We have 3 chlorine, so that's when you trichlorine. And we have 6 oxygen. So you can say hexaoxide, or you can say trichlorine hexoxide. That's because it starts with the hexa ends in a vowel and O starts with a vowel. pH3, again, this is one that has hydrogen in its formula, so it's going to be an exception. So this will be phosphine. And then we want to take the name and write the formula. We have tetrasulfur octabromide. So this tells us we have 4 sulfur and 8 bromine. So the S4Br8. So again, with binary covalent compounds, it's very important that you remember the Greek prefixes. Now we're going to look at hydrocarbons. So with hydrocarbons, we're only looking at compounds that have this CH backbone. And the way we identify the name of these compounds is we use a prefix to identify the number of carbon atoms in the backbone. So we count the number of carbon atoms. They get a prefix, and those prefixes are listed down at the bottom right. So notice these prefixes are, the beginning ones are a little bit different than the Greek prefixes. So 1 is meth, 2 is eth, 3 is prop, 4 is but, but after 4 it becomes similar to the Greek prefixes. So based on the number of carbon atoms in the backbone, you use a prefix, one of the ones shown here. And then you look at the type of bonds. If it's all single bonds, we use the suffix "ane." If it's all double bond, if it has at least one double bond, we use the suffix "ene." Or if it has at least one triple bond, we use the suffix "ane." Now for these hydrocarbons, this is just general chemistry 1. We're just looking at very simple, straightforward hydrocarbons, which will only have one, or they would only have all single bonds, or one double bond, or one triple bond. That's the extent of us naming hydrocarbons. So for example, we have CH4, which is carbon bound to 4 hydrogens. So there's one carbon, we use the prefix meth, and this carbon has all single bonds around it. So we use the suffix "ane," and then we put them together, we get methane. And that's why methane is CH4. Again, the prefix meth because it has one carbon, the suffix "ane" because it's all single bonds. Next we have this compound, this hydrocarbon. You count 1, 2, 3. There are 3 carbons. It gets the prefix prop. You see 3 goes with prop. And they're all connected to single bonds. We get the suffix ane. So this is propane, C3H8, like the propane you buy for your grill. Now when you have a double bond, it's a little bit different. So here we have 3 carbons. We use the prefix prop, but since there's 1 double bond shown here, since there's 1 double bond, we have to use the suffix ene. So this is propene. So notice the difference between propane and propene. Propane has all single bonds. Propene has 1 double bond. So it's very important that you remember these prefixes. Now let's look at some examples. We'll start with some simple ones. So here we want to know the name of this compound here. Let's call this number 1. And you notice that we have 1, 2, 3 carbons. So since we have 3 carbons, we use the prefix prop. Now notice that we have 1 triple bond. And a triple bond is 3 lines. So we use the suffix ene. So let me show you that triple bond. So the triple bond is 3 lines attached to a carbon. So this is the triple bond right here. And so the name of this compound would be propene. Oh, excuse me, propane. So the prop represents 3, the ene represents a triple bond. Next we go to number 2. So here if you count, we go 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbon atoms. So it uses the prefix oct. And it has all single bonds. So we use the suffix ane. And when we put them together, we get octane. So this is the molecule of octane. Oct meaning 8 carbon atoms, ane meaning all single bonds. Now let's look at a more elaborate one. We look at number 3. Here we have 1, 2, 3, 4, 5. So we have 5 carbon atoms. So we use the prefix pent. And you'll notice here that we have 1 triple bond. So we're going to use the suffix ine. But we're not finished here because, let me write it right here. Whenever there's a molecule with more than 3 So this is very important here. Whenever you have a molecule with more than 3 carbon atoms, you need to indicate after which carbon atom the double or triple bond is after. And you have to use the shortest distance to the double or triple bond. So if we look here, if we go this direction, we have 1, 2. So the carbon is, or the double bond's after the second carbon. Because if you go the other way, it's 3. So 2 is shorter than 3, so we have to go with the 2. And this would be 2 pentan. Oops. So you have to include after which carbon the double or triple bond comes after. So 2 pentan is different than 1 pentan. They have different chemical and physical properties. Now, there's no such thing as 3 pentan because 3 pentan is actually 2 pentan because you got to go the shortest direction. So you can have 1 pentan or 2 pentan. Now, if we look at the next example, number 4, we have 1, 2, 3, 4, 5. So again, we use the prefix pent because we have 5 carbon atoms. And you notice here that we have 1 double bond. So since we have 1 double bond, we're going to use the suffix "ene". Now, since it's more than 3 carbon atoms, we have to determine after which carbon the double bond comes after, and we have to use the shortest distance. So we start from the left, we go 1, 2. And so since it's after carbon 2, this would be 2 pentene. So again, if it's more than 3 carbons in the molecule, you have to indicate after which carbon atom the double or triple bond is. Now I want to introduce something else as well, which is pertinent for hydrocarbons, is the following last examples, number 5 and number 6. So if we look at number 5, you see we have 3 carbon atoms. So we're going to, since it's 3 carbon atoms, we're going to use the prefix prop. So again, if we count, we have 1, 2, 3. And you notice that they're all single bonds. And so we use the suffix "ane". But then if we wrote the compound, we would say propane, but this doesn't make sense. Because if it's propane, we looked at propane on the previous slide, and it was different looking than this one. So whenever you notice that the carbons form a ring, so see here they form a kind of like a triangle, or any type of shape that they form where they're all connected to one another, then you have to use the prefix cyclo. So it has a ring, then we use the prefix cyclo. So this becomes not propane, but it becomes cyclopropane. So all the other naming is the same, except now when you see that it's a ring, this is a triangle shape, we use the prefix cyclo. So this becomes cyclopropane. We go to the last example. We notice that it has 1, 2, 3, 4, 5. It has 5 carbons. So we're going to use the prefix pent. And you see there's 1 double bond. Right here. So we have to use the suffix "ene." Now you'll notice that these all form a ring. So if you start at 1, go to 2, go to 3, go to 4, go to 5, you see we come back to the beginning. So since it's that, we have to use the prefix cyclo. Now since we only have, and this is very important, since we only have 1 double bond, any one of these carbons can be the first carbon atom. So we don't have to include the number after which we don't have to include the number of the carbon atom after which the double bond comes after, because it's all, any one of these carbons can be labeled 1. So for example, if we start here, this is 1. Or if we start on this side, this will be carbon 1. So it doesn't matter what carbon you start at when there's only 1 double bond in a ring. You know, any carbon atom can be denoted the first carbon atom. And again, we're only looking at very simple systems. You'll learn more if you take organic chemistry. And so now the name of this compound would be, you can guess it, cyclopentene. Cyclo meaning it's a ring, pent of 5 carbon atoms, ene meaning there's a double bond between 2 of the carbon atoms. And so make sure you remember to review over the prefixes for hydrocarbons and the suffixes, and notice that if it forms a ring, that means they're all connected to one another, not a chain. Then you're going to use the prefix cyclo. So on that note, that's all I have for this lecture on naming covalent compounds, which include binary covalent compounds and a special case of binary covalent compounds that contain only carbon and hydrogen, aka hydrocarbons. I hope you enjoyed the lecture and you learned something from the lecture. If you did enjoy it or you learned something new, please make sure to hit the like button. I always appreciate it when I see that people like the content I post. And on that note, Dr. Armand signing off until next time. See you then.